Hey, welcome back. My name is Sushant Sutish, and I'm your trainer for this AZ-500 Azure Security Engineer Certification course. In this episode, we're going to learn about network security. Let's have a high-level look at the things what we're going to learn in this video. We will start with understanding what is network security groups or NSG, and you will learn how to implement NSGs as well. Along with that, you will learn about what is ASG, which is Application Security Groups. Then we will cover the concepts like service endpoints, private links, etc. Then we will learn about Azure Application Gateway and Web Application Firewall and services like Azure Front Door and ExpressRoute as well. So without wasting any more time, let's get into it. So what is NSGs? Network traffic can be filtered to and from Azure resources in Azure Virtual Network with a network security group. A network security group contains security rules that allow or deny inbound network traffic to or outbound network traffic from several types of Azure resources. For each rule, you can specify source and destination port and protocol. NSGs contain rules that specify whether traffic will be approved or denied. Each rule is based on a source IP address, a source port, a destination IP address, and a destination port. Based on whether the traffic matches this combination, the rule either allows or denies the traffic. Each rule consists of the following properties. The first one is name. This is a unique identifier for the rule. Then we have direction. This specifies whether the traffic is inbound or outbound. Next, we have priority. If multiple rules match the traffic, rules with the higher priority apply. Then we have access. This specifies whether the traffic is allowed or denied. Then source IP address prefix. This prefix identifies where the traffic originated from. It can be based on a single IP address or a range of IP addresses as well. Then we have source port range. This specifies source port by using either a single port number from 1 through 65,535 and a range of ports, for example 200 or 400. Then we have the destination IP address prefix. This identifies the traffic destination based on a single IP address. A range of IP address in CIDR notation or asterisk to match all possible IP addresses. The next one is destination port range. This specifies destination port by using a single port number from 1 through 65,535. The last one is protocol. This specifies a protocol that matches the rule. It can be a UDP, TCP, or it can be an asterisk as well. When implementing NSGs, we need to keep some important limits in our mind. By default, you can create 100 NSGs per region per subscription, and you can raise the limit to 400 by contacting the Azure support team. You can apply only one NSG to a VM, subnet, or network adapter. By default, you can have up to 200 rules in a single NSG. And you can raise this limit by 500 by contacting Azure support. And you can apply an NSG to multiple resources as well. So how is the traffic is evaluated in NSG? Several resources from Azure services can be deployed into an Azure virtual machine. And you can associate 0 or 1 network security group to each virtual network subnet and network interface in a virtual machine. The same network security group can be associated to as many subnets and network interface as you choose. So let's look at some of the general guidelines. Unless you have a specific reason, Microsoft recommends that you associate a network security group to a subnet or a network interface, but not both. So what is application security groups or ASGs? Application security group enable you to configure network security as a natural extension of an application structure. You then can group VMs and define network security policies based on those groups. You also can reuse your security policy at scale without manual maintenance of explicit IP addresses. The platform manages the complexity of explicit IP addresses and multiple rule sets, allowing you to focus on your business logic. You can specify one ASD as the source and destination in a security rule. You cannot specify multiple ASDs in the source or destination. Now let's look at what is service endpoints. A virtual network service endpoint provides the identity of your virtual network to the Azure service. Once service endpoints are enabled in your virtual network, you can secure Azure service resources to your virtual network by adding a virtual network rule to the resources. A common use case of service endpoint is a virtual machine accessing storage. The storage account restricts access to the virtual machine private IP addresses. So why use a service endpoint? The first reason is it will give you improved security for your Azure service resources. VNet private address space can be overlapping and so cannot be used to uniquely identify traffic originating from the VNet. Service endpoints provide the ability to secure Azure service resources to your virtual network by extending VNet identity to the service. Second reason to use service endpoint is it gives you optimal routing to Azure service traffic from your virtual network. So today, any routes in your virtual network that force internet traffic to your premises or virtual appliances known as force tunneling. Also force Azure service traffic to take the same route as the internet traffic. Service endpoints provide optimal routing to Azure traffic. Another reason is endpoints always take service traffic directly from your virtual network to the service on Microsoft Azure backbone network. So keeping traffic on the Azure backbone network allows you to continue auditing and monitoring outbound internet traffic from your virtual networks through force tunneling without impacting service traffic. Another reason is simple to set up with less management overhead. You no longer need reserved public IP addresses in your virtual network to secure Azure resources through IP Firewall. There are no NAT or gateway devices required to set up the service endpoints. Service endpoints would provide so many benefits. So let's look at some of these scenarios. The first one is peered connected or multiple virtual network. To secure Azure services to multiple subnets within a virtual network or across multiple virtual networks, you can enable service endpoints on each of these subnets independently and secure Azure service resources to all of the subnets. Second scenario is filtering outbound traffic from a virtual network to Azure services. If you want to inspect or filter the traffic sent to an Azure service from a virtual network, you can deploy a network virtual appliance within the virtual network. You can then apply service endpoints to the subnet where the network virtual appliance is deployed as well. And this allows you to secure Azure service resources only to this subnet. Another scenario is securing Azure resources to services deployed directly into virtual networks. You can directly deploy various Azure services into specific subnet in a virtual network. The last scenario is disk traffic from an Azure virtual machine. Virtual machine disk traffic for managed and unmanaged disk isn't affected by service endpoints routing changes for Azure storage. This traffic includes disk I/O as well as mount and unmount. Let's understand what are private links. Azure Private Link works on an approval call flow model wherein the private link service consumer can request a connection to the service provider for consuming the service. The service provider can then decide whether to allow the consumer to connect or not. Azure Private Link enables the service providers to manage the private endpoint connection on their resources. There are two connection approval methods that a private link service consumer can select. The first one is automatic. If the service consumer has RBAC permissions on the service provider resource, the consumer can choose the automatic approval method. In this case, when the request reaches the service provider resource, no action is required from the service provider and the connection is automatically approved. And the second connection approval method is manual. On the contrary, if the service consumer doesn't have RBAC permission on the service provider resource, the consumer can choose the manual approval method. In this case, the connection request appears on the service resources as pending. The service provider has to manually approve the request before the connections can be established. Let's understand what is Azure Application Gateway. Azure Application Gateway is a web traffic load balancer that enables you to manage traffic to your web applications. Traditional load balancers operate at the transport layer and route traffic based on source IP address and port to a destination IP address and port. Azure Load Balancer works that way. Application Gateway can make routing decisions based on additional attributes of an HTTP request. Some of the features included in the Azure Application Gateway are Secure Socket Layer or SSL TLS termination, auto scaling, zone redundancy, static VIP, web application firewall, which we will learn in the next slide, ingress controller for AKS, URL based routing, multiple site hosting, redirection, session affinity, and WebSocket and HTTP/2 traffic. New Application Gateway version 1's queue deployment can take up to 20 minutes to provision. Changes to instance size or count aren't disruptive, and the gateway remains active during this time. Most deployment that uses the version 2's queue take around 6 minutes to provision. However, it can take longer depending on the type of the deployment. For example, deployments across multiple availability zones with many instances can take more than 6 minutes. Now let's learn about what is Web Application Firewall. Web Application Firewall or WAF provides centralized protection of your web applications from common exploits and vulnerabilities. Web applications are increasingly targeted by malicious attack that exploits common known vulnerabilities. SQL injection and cross-site scripting are among the most common attacks. Preventing such attacks in application code is challenging. It can require rigorous maintenance and patching at multiple layers of application topology. A centralized web application firewall helps make security management much simpler. A WAF also gives application administrators better assurance of protection against threat and intrusions. A WAF solution can react to a security threat faster by centrally patching a known vulnerability instead of securing each individual web application one by one. So, what is Azure Front Door? Azure Front Door enables you to define, manage, and monitor the global routing for your web traffic by optimizing for best performance and instant global failover for high availability. With Front Door, you can transform your global, multi-region consumer and enterprise applications into robust, high-performance, personalized modern applications and content that reaches a global audience with Azure or HTTPS layer and uses split TCP based Anycast protocol. Front Door ensures that your end users promptly connect to the nearest front door POP. POP means point of presence. Now let's look at some of the features of Azure Front Door. The first one is accelerate application performance. Using split TCP based Anycast protocol, Front Door ensures that your end users promptly connect to the nearest front door POP. Second feature is increase application availability with smart health probes. So Front Door delivers high availability for your critical applications using its smart health probes, monitoring your backends for both latency and availability and providing instant automatic failover when a backend goes down. Another feature is URL-based routing. URL path-based routing allows you to route traffic to a backend pool based on URL paths of the request. The next one is multi-site hosting. Multiple site hosting enables you to configure more than one website on the same front door configuration. Another one is session affinity. The cookie-based session affinity feature is useful when you want to keep a user session on the same application backend. The next one is TLS termination. The front door supports TLS termination at the edge. That is, individual users can set up a TLS connection with front door environment instead of establishing it over long haul connection with application backend. Another feature is custom domain and certificate management. Then you have an ability to add application layer security, URL redirection, and URL rewrite. And finally, you can use it for protocol support, which includes both IPv6 and HTTP2 traffic. So, what are user defined routes? A user defined routes or UDR is a custom route in Azure that overrides Azure default system routes or adds route to a subnet's route table. In Azure, you create a route table and then associate that route table with 0 or more virtual network subnet. Each subnet can have 0 or 1 route table associated with it. If you create a route table and associated it to a subnet, Azure either combines its routes with the default routes that Azure adds to the subnet or overrides those default routes. So, what is network virtual appliances? You can deploy a network virtual appliance to a perimeter network in many architectures. The network virtual appliance provides a secure network boundary by checking all inbound and outbound network traffic and then passing only the traffic that meets the network security rules. However, the fact that all network traffic passes through the network virtual appliance means that the network virtual appliance is a single point of failure in the network. If the network virtual appliance fails, no other path will exist for network traffic, and all the backend subnets will become unavailable. To make an NVA highly available, deploy more than one network virtual appliance into an availability set. So, what is ExpressRoute? ExpressRoute is a direct private connection from your WAN to Microsoft services, including Azure. Site to site VPN traffic travels encrypted over public internet. Being able to configure site to site VPN and ExpressRoute connection for the same virtual network has several advantages. You can configure a site to site VPN as a secure failover path for ExpressRoute or use site to site VPN to connect to sites that are not part of your network but that are connected through ExpressRoute. Azure Virtual WAN uses Internet Protocol Security or IPsec or Internet Key Exchange, which is IKE VPN connection from your on-premises network to Azure over the private peering of Azure network of an Azure ExpressRoute circuit. This technique can provide an encrypted transit between the on-premises network and Azure Virtual Network over ExpressRoute without going over the public internet or using the public IP address. And finally, what is ExpressRoute Direct? ExpressRoute Direct gives you ability to connect directly into Microsoft Global Network at peering location strategically distributed across the world. ExpressRoute Direct provides dual 100 Gbps or 10 Gbps connectivity, which supports active-active connectivity at scale. So, what are the features of ExpressRoute Direct? ExpressRoute Direct gives you massive data injection into services like storage and Cosmos DB. Another feature is gives you ability of physical isolation for industries that are regulated and require dedicated and isolated connectivity like banking, government, and retail. And this provides granular control of circuit distribution based on business unit as well. All right, so that concludes this episode. In the next video, we're starting a new episode which is all around host security. So I will see you on the next one. Till then, take care.